Latest release AI models this week are here, and they're packed with innovation. Get ready to explore the cutting edge of AI. In this video, we'll delve into 6 fascinating projects: the Hugging Face Model Atlas for visualizing AI, MM-EUREKA for multimodal reasoning, CSM for context-aware speech, OLMo 2 the truly open language model, Command-A focusing on efficient performance, and Gemma 3, Google's powerful yet lightweight open AI. Prepare to discover what makes each of these releases unique and their potential to shape the future of AI. Model number 1, introducing Gemma 3, Google's powerful and portable open model. Today, we're diving into something truly groundbreaking: Gemma 3, Google's latest family of open AI models. What makes Gemma 3 so unique? Well, for starters, it's built upon the very same research and technology that powers Google's cutting-edge Gemini 2.0 models. This means you're getting state-of-the-art performance, but here's the kicker: Gemma 3 is designed to be incredibly lightweight and efficient, so much so that it can run directly on your everyday devices like phones, laptops, and even workstations. Forget needing massive server farms. Gemma 3 is engineered for single GPU or TPU applications. But don't let the small size fool you. Gemma 3 punches way above its weight, outperforming other models in its class, even giving giants like Llama 3-405B a run for their money in human preference evaluations. This opens up a world of possibilities for developers to create engaging AI experiences without breaking the bank or requiring supercomputer-level hardware. Plus, Gemma 3 is truly global, supporting over 140 languages right out of the box. Imagine building applications that can understand and respond in virtually any language your users speak. Beyond text, Gemma 3 also boasts advanced text and visual reasoning capabilities, allowing for the creation of intelligent apps that can analyze images and short videos. And for those complex tasks, Gemma 3 offers a massive 128K token context window and supports function calling, enabling sophisticated AI-driven workflows. To top it all off, Gemma 3 comes with official quantized versions, delivering high performance even faster and with reduced computational demands. It's all about bringing powerful AI directly to your fingertips, wherever you need it. Model number 2, introducing Command-A, max performance, minimal compute. We're taking a look at something really interesting in the world of AI: Command-A. What makes Command-A stand out in a sea of language models? Well, the name itself gives you a big clue. It's all about achieving maximum performance with minimal computational resources. This isn't just marketing speak. Command-A is engineered to be incredibly efficient, allowing it to tackle complex tasks without requiring massive amounts of computing power. In fact, early reports indicate that Command-A performs on par or even better than industry leaders like GPT-4o and DeepSeek V3, specifically when it comes to agentic enterprise tasks. And it does so with significantly greater efficiency. Think of it as getting top-tier results without the hefty overhead. This focus on efficiency is a game-changer, potentially making advanced AI capabilities more accessible for a wider range of applications and businesses. Command-A is part of Cohere's family of high-performance, scalable language models. While the broader Cohere platform offers tools like Embed for search and retrieval and North for workplace integration, Command-A's core differentiator lies in its powerful performance coupled with its lean computational profile, making it a compelling option for developers and companies looking for cutting-edge AI that's also cost-effective and scalable. It represents a step towards democratizing access to advanced generative models by emphasizing not just capability, but also practicality in terms of deployment and resource utilization. Model number 3, introducing OLMo 2, truly open and surprisingly powerful language models. We're taking a look at OLMo 2, the latest series of open language models from the Allen Institute for AI. AI2. What makes OLMo 2 stand out in the rapidly evolving world of language models? Well, the name says a lot. It's fully open source. This isn't just about releasing weights. It's a commitment to transparency and community access, allowing researchers and developers to delve into every aspect of the model. But being open doesn't mean sacrificing performance. In fact, OLMo 2 in its 7B and 13B parameter versions demonstrates very strong capabilities within its class, even outperforming models like Llama 3.18B Instruct and Qwen 2.5 Instruct on multi-skill evaluations. This achievement is particularly noteworthy considering the relatively small team at AI2 behind this effort, often operating with significantly fewer resources compared to major technology companies. Their dedication is focused on making tangible progress in fully open models. OLMo 2 represents a step towards truly usable open-source AI, with the 13B Instruct model being highlighted as genuinely good enough for practical applications. The development team emphasizes the accumulation of minor improvements and a willingness to prioritize impactful work, showcasing that significant progress can be made through focused effort. Furthermore, they are committed to sharing technical details through blog posts and forthcoming papers, contributing to the collective understanding of language model training. OLMo 2 embodies the potential of open collaboration to drive innovation in AI. Model number 4, introducing MM-EUREKA, the first multimodal rule-based reinforcement learning framework. We're diving into a fascinating project called MM-EUREKA, and what makes it truly stand out in the world of AI is that it's breaking new ground by being the first to successfully extend the power of large-scale rule-based reinforcement learning, RL, into the realm of multimodal reasoning. Now, you might have heard about how rule-based RL has significantly boosted the reasoning abilities of large language models in text-based tasks, and MM-EUREKA takes this success and for the first time brings it to models that can understand both text and images. This is a big deal because it means we can now train AI to reason more effectively about complex problems involving visual information, mirroring some of the key advancements seen in text-only RL systems like DeepSeek R1, such as steadily improving accuracy and the ability to reflect on its responses. What's even more impressive is that MM-EUREKA demonstrates that both instruction-tuned and pre-trained models can achieve strong multimodal reasoning skills through this rule-based RL approach without needing lots of labeled data, showing superior data efficiency compared to other methods. The creators are also open-sourcing their entire pipeline, including all the code, models, and datasets, which is fantastic for fostering more research in this exciting area. Built upon the foundation of OpenRLHF, MM-EUREKA adds crucial support for vision language models like InternVL, along with enhancements for rule-based rewards and online filtering to optimize training. They've even provided an evaluation benchmark with their new K-12 math dataset. So, if you're interested in the cutting edge of AI research, particularly in how we can teach AI to reason across different types of information, MM-EUREKA is definitely a project to watch. Model number 5, introducing CSM, Conversational Speech Generation that Listens. We're taking a look at a fascinating project from Sesame AI Labs called CSM, which stands for Conversational Speech Model. What makes CSM particularly interesting is its focus on generating realistic and context-aware speech. Unlike many text-to-speech systems, CSM goes beyond simply reading out words. It's designed to understand and respond within a conversation by generating RVQ audio codes directly from both text and even other audio inputs. This means you can provide it with a history of the conversation, using segment objects to define each speaker's turn, and CSM will use this context to generate its own audio response, potentially making the interaction feel much more natural. The model achieves this by employing a unique architecture that combines the power of a llama backbone, a well-known large language model, with a smaller, specialized audio decoder that produces MIMI audio codes. This hybrid approach likely allows CSM to leverage the linguistic understanding of llama for generating relevant speech while efficiently creating the audio output. It's also noteworthy that Sesame AI Labs has open-sourced a 1 billion parameter variant of CSM, with the pre-trained weights available on Hugging Face, making this technology accessible to researchers and developers. While it's important to remember that CSM is primarily an audio generation model and doesn't generate text itself, you'd need a separate LLM for that part of a conversational system. Its ability to generate speech that takes conversational context into account is a key differentiator. This focus on contextual awareness and the innovative model architecture makes CSM a unique and promising tool in the field of speech generation. Model number 6, Hugging Face Model Atlas, your guide to the AI universe. We're exploring a fascinating project called the Hugging Face Model Atlas, and what makes this tool truly unique is its innovative approach to understanding the massive and ever-growing landscape of publicly available AI models. Think of it like this. Instead of just a giant list of models, the Model Atlas visualizes them as a dynamic map, a graph where each model is a point and the connections between them represent how one model was transformed into another, for example, through fine-tuning. This visual representation immediately offers a level of insight you just can't get from browsing a repository. What's particularly cool is how the atlas highlights different regions, like Stable Diffusion and Llama, revealing distinct characteristics. For instance, we can see that the Llama ecosystem has a far more intricate structure with diverse transformation methods like quantization and merging compared to Stable Diffusion. Moreover, the size of each model's node on the map even tells you about its popularity based on download numbers. But it goes beyond just visualization. Since many models lack complete documentation, the atlas uses its structural knowledge to predict missing information about models, such as their accuracy or even their popularity, just by looking at their neighbors on the graph. And for those mysterious, undocumented areas of Hugging Face, the project pioneers a method to chart them by identifying fundamental patterns in how models are typically developed and trained in the real world, allowing us to map even the unknown parts of this vast AI universe. And that wraps up our look at some of the most exciting recent AI releases, from mapping the AI world to enabling multimodal understanding, natural speech, open access, efficient computing, and powerful on-device AI. Let us know in the comments which project sparked your interest the most and what AI topics you'd like us to cover next. Don't forget to like this video, subscribe for more AI deep dives, and hit the notification bell so you don't miss our future content. Thanks for tuning in.